Hello everyone, hope everyone's doing well. So today we will see lecture number 12 from design and analysis of an algorithm. Today's topic is about recursion trees. If we have any recurrence, how can we solve that using building the recursion trees basically? What we have to do is we have to convert the recurrence into a tree. Okay, and in each tree, each node represents the cost incurred at various levels of recursion, how much cost it would incur in order to develop a tree, and then in order to find the total value we have to sum up the costs of all levels. Say the recurrence which we have to solve is this: t of n is equal to 3t n divided by 3 plus constant amount of time. That means this is a recurrence, an equation of any problem whose time complexity on n input size is that the problem is divided into 3 subproblems, and each subproblem is of this size, plus it is doing some constant amount of time. How can we build a recursion tree and solve this? So what we have to do is we have to start building a recursion tree starting with a single node, and that single node is this t of n. In each step we will replace this t of n or t of n divided by b. In general, we will replace these t's with their corresponding values as given by the right hand side of the equation. But we don't simply write the right hand side equation by linear equations, but we will explain it diagrammatically. So that means this t of n will be replaced by constant times n, that means c of n with 3 children's, with 3 children. Okay, so we can build the tree for this as, firstly this will be the upper node constant times n with 3 children's, and 3 children's are 3 children. This would represent how many children? 3 children, and each children is of this size. We don't have to write 3, but we have to mention the size of the tree. This is the first round of applying the recursion tree on this equation. You always have to remember at this particular time, after applying the first round of recursion on this particular recurrence, the value of t of n is the sum of the values of these nodes. How many nodes we are having? 1, 2, 3, 4. So t of n will be equal to constant times n plus t of n by 3 plus t of n by 3 plus t of n by 3. We can expand this tree. This is when we apply only the first round of recursion. That doesn't mean after applying the first round of recursion we completely solved the problem. No, we have to keep on dividing this problem till the last problem, till the last subproblem would be of size 1. That means we must get a problem of size 1. So if we will expand this further, what we have to do is, that means now we have to replace t of n by t of n divided by 3, isn't it? Now what we have to do, we have to take this in this place, at this place. Okay, we have to take t n by 3 at this place, then we have to expand it more. So how can we do that? So this t of n we have to replace with t n by 3. So that means our recurrence will be like this: 3 times t n divided by 3 into 1 divided by 3 plus constant times n divided by 3, which will be equal to 3t n divided by 3 into 3 is 9 plus constant times of n divided by 3. Now replace this. Now t n divided by 3 will be equal to constant times n of this. Okay, we have to replace these threes. That means how many children we are having? 3. Constant n divided by 3, constant n divided by 3, constant n divided by 3, and each this would be having of size n divided by 9, t n divided by 9, n divided by 9. Similarly, 3 over here, 3 over here, each of size n divided by 9, n divided by 9, n divided by 9. Similarly over here, t n divided by 9, t n divided by 9, t n divided by 9. You always have to remember that we at after applying the second level of recursion, the value of t of n at this point, this will be t of n, okay, at this point will be t of n will be equal to constant times n plus constant times n divided by 3 plus constant times n divided by 3 plus constant times n divided by 3. You always have to remember we have 3 times n divided by 3, so we have to replace it at 3 times. We wrote 3n by 3, 3n by 3, 3n by 3 because we have to replace this at 3 places, then the 3 children of each node, plus tn divided by 9 plus tn divided by 9, and so on till we will do the summation of each and everything. Similarly, if we will apply the third round of recursion over here, then we have to replace this t of n divided by 9. So obviously it will be tn divided by 27, and we have to replace it like that. Okay, so imagining replacing each tn of 9, and by this level we can create another level of recursion, and we have to keep on doing the recursions till we will get the last sub problem as, let me draw it once again so that you will understand it in a better way. So the final tree would be like this. Right? Then this would have their own 3 childrens, like C, instead of T this will be C because we are to replace it. Then we have C27, C, n by 27, C, n by 27, and so on. We have to keep reducing this recurrence by using the recursion trees till we will get the sub problem of size 1, at each level. So if we will keep doing this, opening the values of these t's into smaller subproblems until we hit the subproblem of size 1, that is where we have to stop. We will keep creating more additional levels of this tree by opening up recursion equations of these t's till we will end up with levels each of which will have the value of t of 1. Like don't get confused, this c of n would be over here, then each c of n would be having its own levels, the same levels. We have to keep on doing this till we will get the subproblem of size 1, and we will hit the bottom when all the nodes that will when we have which we have as t of 1 subproblems are decreasing at the same rate along all the paths in the same tree. So we will hit t of 1 everywhere uniformly. So always remember, this is what we called as a level. Okay, this is level 0, this is level 1, this is level 2, so this is level 3, and similarly somewhere we would be having a level, ith level. Say at the ith level, instead of this will be c n divided by I 3 raised power some I, because you can see it over here. And similarly we would be having the hth level. If we will calculate the nodes at each level, at the 0th level, how many nodes we are having? 1. At the first level we are having how many nodes? 3 nodes. At second level we are having 3 squared, that means 9 nodes. At third level we would be having 3 ka cube, that means 27 nodes, and so on. At ith level we would be having 3 raised power ith nodes in total at the ith level. And similarly at the last, when we will hit the subproblem of size 1, we would be having, let that be equal to h, we will be having 3 raised power h number of nodes at the last level. Now the question is, how do we evaluate the value of t of n? How can we evaluate it? How can we evaluate the value of t of n? As we saw, we do so by summing of the costs at each node at all levels in the recursion tree. So the question is, how do we evaluate the value of t of n? How can we do that? At each level we calculate the sum. Say at level sum we calculate 2, 3, I, and similarly at the hth level. Okay, at the 0th level, how many nodes we are having? 1, and that is c of n. At first level we have 3 times c n divided by 3, isn't it? Like this. At first level we have 3 times c n of 3. At the second level we have 3 ka square constant times n divided by 3 ka square, isn't it? N by 9. And at 3 cube we would be having c into n divided by 3 ka cube, and so on. Similarly at the 3 ith level we would be having c n divided by 3 ka I, isn't it? And at the hth level we would be having 3h into constant amount of, no, we would be having t of 1, as the hth level is the last level where each and every node is having a size of t of 1. Okay, it means that further we cannot divide this bigger problem into a smaller problems. Now you can see that the level sum is same at all levels, isn't it? Right? But at the last level you can have 3 raised power h into t of 1. Okay, what will be the previous level of the level A? Level h. Level h का जो previous level है वो क्या होगा? That will be 3 raised power h minus 1 into c of n divided by 3 raised power h minus 1, isn't it? ठीक? So this is how we calculate, which is basically nothing equal to c of n, right? So this is how we do evaluate the value of t of n. So this was all for today's lecture. That was about the recursion trees. This is how we basically build the recursion trees. We keep on dividing our problems into smaller sub-problems till we hit the sub-problem of size 1. Thank you so much. Have a nice day.